Good morning, ninth. It's been time for online classes from your own school, Panacea Public, and with your own teacher, Gurpreet. So let's not waste the time. The next part of our video deals out with graphical graphical representation of motion. Representation of motion. I want you people to just pay attention here because this is for the first time where you people are going to feel like, yes, we are in ninth. It's not going to be easy. And I'll be very slow with this. Graphical representation of motion. But before entering into this concept, we must remember last few things. Speed is equals to distance upon time. This is what we have done. Velocity, displacement upon time. Acceleration, change in velocity upon time taken. If you remember these things, then you are welcome to my this lecture because these are very important. Why I am writing this, and please once more go with this. Speed is equals to distance upon time. Velocity is equals to displacement upon time. Acceleration is equals to change in velocity upon time. You have to remember this. In this concept or in this like upcoming topics, we will be given some graphs. Like for example, this is distance time graph. Distance time graph. For example, this is for uniform motion, it must be a straight distance time graph. Then we will be given in the same way displacement time graph. This is for example a displacement time graph. This is also a linear motion. And then we will be given, of course, the third one, that is velocity time graph. You can say that if it is been velocity time graph, then what we will get from there. If it is speed time, or you can say that velocity time, no issues with that. Your book is been following velocity and speed together, no issues, either velocity time or speed time. Okay bacho, exactly, we have done this, that speed and velocities are just same. The only difference is off. That is direction. Now if velocity time graph, such kinds of graphs you are going to study, but for what purpose? Look bache, I know with the help of distance and time ratio I can find speed. Same here. From distance time graph we can find speed. By the ratio of displacement time we can find velocity. Same is the case by the graph of displacement and time we can find velocity. Same here. Velocity and time gives me acceleration. Same is the case. Velocity and time gives me an acceleration. But the question, how? How, like I'll be getting from here. So before doing this, let us come to a new word, what they call it as slope. Now this is a totally new word for you people. Let me take this slope with a daily life example. Look, I'm making two mountains. One is this sort of mountain is there. This is a mountain A. This is second mountain. This is B mountain. Now tell me, like on which mountain, if I'll place, look, here one ball is been there, one ball I placed and one ball I placed here. Now, from which mountain the ball will fall quickly or the ball will roll quickly to the earth? Everybody's answer will definitely be A. Why? Because we used to say, like here, the slope is more. Now, what is slope? ये जो ढलान है, this is called slope. Like how much slope is there? Look, now if I'll ask, which mountain is easy to climb? A mountain is easy to climb or B mountain is easy to climb? Then the answer will be B. Because here that slope is less. Now this is exactly slope. Slope means how much something is being from the ground, like how much it is at some angle with the ground. Look here, here the angle is less, that's why the slope is less. But if I'll increase this angle, slope is also increasing. It means it is very easy or exactly true to say that this angle is responsible for the slope. Where the angle is large, look, for example, here it is 45 degree, then slope is also more. Here the angle is 30 degree, then the slope is less. Means slope depends upon these angles.